The purpose of this video is to go over in detail the solutions to this MCT4C final exam review. And so I'll flip right to the beginning of the first multiple choice question. And in it, you're given these two curves and asked to find the point of intersection. Well, this is the x-coordinate, there's the point of intersection right there, would be 1 or very close to 1. And the y-coordinate would go horizontally from that point over to the y-axis. See, that's 15, so it would be just a little bit above 15. Looks like it's around 16. So that's why the answer should be B here. Even a point like 0.918 isn't too far from 116, but that would mean the x-coordinate's a little bit to the left here a bit, and the y-coordinate then would probably be lower, so 18 is too high. It's certainly, the closest point is 116. For the second page, number 2 here, and 3, 4, and 5 also relate to the same four graphs here. Which of the following is an exponential curve? Well, this is the shape of an exponential curve, so for 2, the answer is A. For number 3, which is a trigonometric curve? This is the shape of a trigonometric curve, a sine curve or a cosine curve. So D is the correct answer for number 3. For number 4, which is a quadratic curve? This is a quadratic or a parabola. So for number 4, B would be the correct answer. And for question number 5, this is a linear relation or a linear function. And so for number 5, C would be the correct answer. For number 6, we're asked to multiply 4 cubed by 4 to the 7th. And so 4 cubed times 4 to the 7th, we're multiplying two powers with the same base. And so you add the exponents to get 4 to the power of 10. If you want to know why we add the exponents, 4 cubed means 3 4s multiplied together. Remember, the exponent is how many of that base we're multiplying. 4 to the 7th means there's 7 4s multiplied here. So altogether, there's 10 4s multiplied, which is what 4 to the 10th means. That means 4 times 4 times 4, 10 times. A really common mistake here is to multiply the 4 and the 4 and think it's 16 to the power of something. But it's not 16s we're multiplying here. The bases are all 4. So it's all 4s we're multiplying. So that's why it's 4 to the power of 10. For number 7, we're asked to solve 2 to the x equals 64. So this really means what power do you raise 2 to get 64? So in order to solve this, what we would want to do is write the 64 as a power of 2. And it would look like this. And in your calculator, see, there's 2 to the power of 6 equals 64. If the exponent is fairly big in what you're writing, you're trying to write one number as a power of some other base, then you can use the logarithm function in your calculator to find that. So if I want to write 64 as a power of 2, you can divide the 64 number by the base, the log of the base, sorry. And if you do that, you get 6. So that means that this 2 right here raised to this power of 6 would equal to 64. And so that's why for number 7, D is the correct answer because x is 6. For number 8, we're taking what's called a power of a power. So 3 squared to raise to the power of 5. Now, power of 5 means there's 5 of these 3 squared. So it's like a 3 squared times another one. There's 5 of them all together. So this is really 2 3s and another 2 3s and another 2 3s and another 2 3s and another 2 3s multiplied. So altogether there's actually 10 3s here. There's actually 5 pairs or 5 sets of 2. So that's why you multiply the 2 and the 5 to get 10. And so 3 to the 10th would be the correct answer for number 8. For number 9, 7 to the power of x equals 500. You have to express that in its equivalent logarithmic form. Now, the base of the power is also the base of the logarithm. So it's logarithm base 7. Now, C also has a logarithm base 7, but the exponent, the x here, is what the logarithm's equal to. So x equals the logarithm base 7 of the other number, the 500. To convert from logarithmic form back to exponential form, I always think of it like this. This base raised to that power is equal to that number. And that's what this exponential form says. 7 to the power of x equals 500. For number 10, we're asked to evaluate the logarithm of 300 base 5. And chances are you don't have a calculator that does base 5, but it will do base 10. So what you can do is take the logarithm of 300 and divide it by the logarithm of the base, and you should get 3.54. It should look like this. And so we evaluate that, you get 3.54, so to 2 decimal places it's 3.54. And so for number 10, that's why B is the correct answer. For number 11, you're asked which of the following is a polynomial expression. This is a polynomial expression. A polynomial expression, whatever the variable is, whether it's x or something else, it's always raised to the power of positive whole numbers. So 3, 2, 1, 10, 5, 7, 9, those kinds of things. The coefficient in front, like the 4, the -2, the 7, -11, they can be any numbers, they can be fractions, they can be negative numbers, but the exponents can only be positive whole numbers. In B here, this is most of this is polynomial, but this would not be. And the reason is you can't have a power of x in the denominator, a power of x with a whole number like 2. Because if you were to actually bring that x squared up, it would actually look like this. If you remember the negative exponent thing, when you bring that x squared up, it would actually become x to the power of -2. So you actually have an x with a negative exponent, so that's why it's not polynomial. That's actually called a rational function. In C here, the x is in the exponent, so this is an exponential expression. And as soon as you see a cos or sine or tan, that's a trigonometric expression. For number 12, and actually 13 relates to this graph too, we're asked what is the end behavior of this function shown? And so one way to state the end behavior is what happens to y as x goes to the far left or x goes to the far right. So as x tends towards negative infinity, the graph goes way down, the y's become very large negative numbers, so y would be tending towards negative infinity or a very large negative number. As we go to the positive right here, as x becomes large, x tends towards infinity, y again tends towards a large negative number, so we say it tends towards negative infinity. So A is the correct end behavior for this function shown. Another way to say it is the function goes from quadrant 3 here to quadrant 4 over here. So it's going from 3 to 4. Remember, you read that from left to right across the page. For number 13, you're asked what's the proper mathematical term for the point 1, 4, which would be this point right here. And that point is called a local maximum point. A maximum because if you go from that point a little bit to the left or a little bit to the right, the graph's lower. So it's like the highest point on that part of the curve. It's actually also called the absolute maximum because it is the highest of all the points in the curve, but it's properly called also a local maximum. This is another example of a local maximum here because a little bit to the left or a little bit to the right, it's lower than that point. This is a local minimum point because a little bit to the left you're going up or a little bit to the right you're going up, so it's the lowest point on this part of the curve. So that's why for 13, D would be the correct answer. For number 14, which of the following statements correctly describes this function? And you look at the highest power of x term, or whatever the variable is. Since the leading coefficient is negative, it's a negative function, and the x to the power of 4 means it's quartic. And that doesn't always have to be listed as the first term, so we could have the highest power of x somewhere through here. Okay, so don't just look at the first term, but that is where the largest power of x is. And so that would be called a negative quartic function, which is answer C. For number 15, we're asked to rearrange v equals pi r squared for h. So I would write v equals pi r squared h. And the pi and the r squared and the h are all three things multiplied together. I want to get the h alone, so that's why I would divide both sides by pi r squared, so that these pi r squareds divide out. And on the right side, I have only h now, so that's why h would equal this, the v over pi r squared. So C is the correct answer for number 15. For number 16, you're asked what's the exact value for the cos of 150? Now you can use the unit circle at the end of the review here, or it's also on the exam, and it looks like this. So again, it's the cos of 150 we're finding. And on the unit circle, as you rotate from around the circle in a counterclockwise fashion, each angle goes to the point right after it. So that's 30 degrees, 45 be looking here, 60 be looking here. So for 150, we're actually looking at this point. This says the cosine is the x-coordinate, the sine is the y-coordinate. So for the cosine of 150, we'd be looking at this number. Its exact value would be negative root 3 over 2. Just to demonstrate that that's correct, you actually could take your calculator, like if you weren't really sure that that was right, And you can do this. Make sure it's in degree mode to do this. The cosine of 150 is what we're trying to find here. So it's negative 0.866025, etc. If you punch in your calculator that negative root 3 over 2 that we thought was the correct answer, notice it works out to exactly the same decimal. So that's a demonstration that the cos of 150 should be negative root 3 over 2. For number 17, in a right angle triangle, we're asked what the tan ratio is equal to. And remember your SOHCAHTOA, tan is opposite over adjacent, which is answer B here. For number 18, we're asked to find the angle theta. We're told the sine of that angle is 0.9848. This is actually what you would punch in your calculator, the arc sine or inverse sine of 0.9848, and you should get 80 degrees. This is what it would look like in your calculator. So that's what it looks like, 79.997 degrees, so we round that to 80 degrees. It's pretty close to 80. For question number 19, a vector is represented graphically by using, graphically means to draw it, directed line segment. So C is the correct answer for 19. And for number 20, we're asked to convert 20.3 meters into centimeters. Well, 1 meter is equal to 100 centimeters. So we'd multiply that 20.3 by 100 and get 2030, and so that's why B is the correct answer for number 20.